Welcome to aplusbi. This channel is all about complex numbers, and in this video, we're going to be solving an interesting problem, a trigonometric problem with complex numbers. So we're going to be evaluating cosine of a complex number, 1 minus I. How do you find the cosine of something that doesn't even exist? Well, complex numbers exist and they're everywhere, but they're just called complex, and I is called the imaginary number or imaginary unit, whatever. If you're new to complex numbers, go ahead and check out my lecture videos. If you like algebra, number theory, and trigonometry problems, go ahead and check out my other channel, Cyber Math, Cyber with an S. All right, great. Let's see how we can solve a problem like this. Cosine of 1 minus I. How do we find that? We're going to use Euler's formulas, and Euler is just awesome. He's the best, right? Don't you think? If you disagree, let us know and why you disagree in the comment section down below. So to find the cosine of something like complex, we're going to consider the following. E to the I theta is cosine theta plus I sine theta. If I replace theta with negative theta, I get cosine theta minus I sine theta because cosine is even. And then from here, by adding these two equations side by side, we get an identity for cosine. 2 cosine theta becomes the sum. In other words, to keep a long story short, I just wanted to show you real quick. I know some people don't like repetition, but I think people need repetition once in a while. And not everybody is at the same level. I mean, not everybody's doing a PhD in math, guys. Come on. So just relax and enjoy the math. And ask questions. That's how you learn. So this is cosine theta. And what I'm going to do is I'm going to replace theta with 1 minus I. And that's going to be pretty interesting because we're going to use Euler's formula one more time. Okay, cool. Now let's go ahead and do this. We're going to replace theta with 1 minus I. And by the way, we're going to get a complex numbers from here. The cosine of a complex number is also complex. And I'll show you the result from Wolfram alpha, which we can kind of approximate. Okay. So under this, cosine of 1 minus I becomes e to the power I times theta, which is 1 minus I, plus e to the power negative I times theta, which is 1 minus I, and that is divided by 2. Great. So that's the answer. It's on the right-hand side. There you go. But let's simplify it. To simplify it, we're going to go ahead and first distribute this. We're going to get e to the power I minus I squared and e to the power negative I plus I squared. And of course, these two things are going to be opposites. I squared is negative 1, so negative I squared is positive 1. That gives us e to the power 1 plus I, and its opposite, e to the power negative 1 minus I. Get the idea? Divided by 2. So that should be the answer, and that should be good enough for many, or I think for many purposes, right? That should be good. But let's dig a little deeper. What is e to the power 1 plus I? So from cosine, now we are going to the exponential. Make sense? Okay, let's explore a little further. So what is e to the power 1 plus I? There's a couple ways to look to this. You know that we have e to the I theta is cosine theta plus I sine theta. But here notice that nothing is multiplied by I. So we don't really have I times 1 minus I times theta. Or in other words, if I ask you this question, what is theta here? Can you tell me right away? Not really. I mean, if you write it as this, e to the power I times 1 minus I, and then yes, this becomes the theta. But guess what? It's not going to help you. It's just going to give you cosine 1 minus I, trust me on that, equals cosine 1 minus I. It's kind of like a circle reasoning, right? You don't want to go around in circles. You want to find a different version of the answer. So here's what we're going to do instead. Forget about this. We're going to explore e to the power 1 plus I. First of all, the exponents are added. What does that mean? It means we can go ahead and write this as e to the power 1 times e to the power I. E to the power 1 is just e. That's well understood, I think, right? The tricky part is e to the power I. So how do you raise e, which is a transcendental number, to an imaginary power? Okay, again, by using our superpowers or Euler. We can do that. Think about it. What would be theta if you had e to the power I? Well, that would mean e to the power I times 1. So theta would be 1. But be careful. You've been warned. Theta must be in radians, not in degrees. I'm not talking about 1 degree. I'm talking about 1 radian. So e to the power I can be written as cosine of 1 plus I sine of 1. Beautiful. Again, 1 radians, not 1 degrees. I don't like writing the degree symbol, so a lot of times people are confused and they say, why aren't you writing it? Because I don't like it. But here, I'm telling you, the angles are in radians, okay? Make sure you establish that, because think about it. When theta is not in radians, even the formula like limit as theta approaches 0 of sine theta over theta equals 1, this does not work. Theta must be in radians. What happens if theta is in degrees? Then you adjust it. That's a different story. We're not going to worry about it, but you know, that's what it is. So now we know e to the power I is that. What else do we need? We do need e to the power negative I, because we have the following. Let's go ahead and rewrite it so we can kind of break it down in a better way. So now we can go ahead and write this as 1/2 on the outside, e to the power 1 times e to the I minus e to the power negative 1 times e to the power negative I. So all I have to find is two things, this one, and guess what? These two are reciprocals, so if I can just find e to the I, I'm just going to flip it, right? And I already did. Look, this is e to the I. So if e to the I is that, if e to the I is cosine 1 plus I sine 1, what do you think its reciprocal is going to be? Because its modulus is 1. Am I making sense? I hope so. It's going to be its conjugate. So like this. That's e to the power negative I, and you can test it out. So we got everything we need. Let's go ahead and plug it in. So again, one more time, cosine of 1 minus I is equal to e to the power 1 plus I, or 1/2 times e times e to the power e times e to the I minus e to the power negative 1 times e to the power negative I. I'm going to do the replacements now. 1/2 of e times cosine 1 plus I sine 1 minus e to the power negative 1 is 1 over e times cosine 1 minus I sine 1. How nice is that, right? This is just the cosine of an angle. It has a lot of components. Let's go ahead and put the real parts together, shall we? Maybe we can still keep the 1/2 on the outside and put the e cosine 1 minus 1 over e cosine 1 together. And then I sine 1. And this is going to be like a double negation, I think, plus I sine 1. Otherwise, they would cancel out, leaving us with a real number, which we don't want. So here we're going to be getting something like e minus 1 over e multiplied by cosine 1 plus 2I sine 1. And of course, the whole thing needs to be divided by 2, which you can do if you want to write this a little differently, or just put a giant 1/2 all the way in the front, and that should be the answer. Let's go ahead and check out our results with Wolfram Alpha if I did not forget to include the results. Are you ready? Ta-da-da-da, yes, I have it. Uh-oh, what is that supposed to mean? Kosh? Well, it's hyperbolic cosine. And think about what this means. But anyways, that's a different story. The decimal approximation is 0.83 maybe plus 0.99i. Something like that, pretty close to 0.8 plus 1i. Again, that is the cosine of 1 minus I. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.